So we have all the information we need to go ahead and write our equation. So I'm going to start with my y equals my ax squared. My a is going to be negative 71.48. So let me put that in. Negative 71.48 x squared, so that's coming from here, plus my b. Whoa, that's a big B, so give yourself some room. That's one downside of using the years instead of saying 1, 2, 3, 4, 5. You do get really big numbers out. X, that's coming from right there. And then plus your C is actually going to be a minus a C because our C is negative. So I'm going to write that on the next row because I'm out of room. So minus 2, 4, 4, 6, 2, 4, 8, 4, 6.3. Wow, that was a big number. So now for 5B, it says, what would you expect the population of the town to be in 1845? So we have X's and Y's, so the year would be an X. So X is 1845. So what we need to do is plug in. So let's start by saying our negative 71.48 times our 1845 squared. So I use the square key over down here. And then we need to say plus 264472.33 times x, which is 1845 again. So we're plugging in this x for the x values in our equation. And then finally, it says the minus that big number right there. So we're going to say minus 244624846.3. Ooh, all that work for a very small number comparatively. So we have, once again, we're not going to round halves of people here. We're going to just round it to the whole number, not up but down. So we're going to say 6895. So 6,895. So for people, don't round up, round down. Our next section right here, for 6 and 7, gives me another table, and it just wants me to write the equation. So this is actually a little bit easier than what we did last time. But the difference here and why I put it on here is they wrote these as fractions. So what I'm going to do is say stat, edit. So that was my stat button, and I hit the first thing once again. I'm going to go up here and hit clear and down to clear out my list. So I go up to the L1, I hit my clear button over here, and I press the down key, and that clears out the whole thing. So I get to put in my list 1, 2, 3, 4, 5, 6. That was easy. And over here I get to put in 4, 6, 7, 9, 10, and 10 again. Now it told me line of best fit, so I know I'm going for stat, calc, and I'm going to go for option number 4, linreg. So I'm going to hit the 4 this time, and that will take me right there. Hit enter, and there you go. You get all your information. You get all your information ready to go. Sorry, that was my dog. He needed a little hand, I guess. Alright, so we got a couple things. First off, we can eliminate a little bit. My A is positive, so I can eliminate the A's here that are negative. Sorry. I know, now he wants to be in the video. And then we've got 1.25. That's 1 1/4. So it should be a little bit bigger than 1. So that's going to be D. That's 5/4. Usually we can math to fraction, but that's not helping us at all on this one. So we're going to have to estimate just a little bit on our part there. All right. One more. Number 7. Thank you, puppy. Sorry. Which is the most likely equation of the line of best fit for this set of data points above? So I don't know how well you can see all those points, but we can definitely kind of estimate a line here. This is not a calculator problem. This is an estimating problem. And you can estimate a line that looks kind of like that going through all the points. Now we know it's a negative line because it's going down from left to right, so it's falling. So we're going to eliminate the ones with the positive slopes. So our slopes are this part right here in front of your X. Then these have two different slopes. One says down 2 over 5. The other one says down 5 over 2. So we're talking about rise over run and slope-intercept form now. So let's test it out. If I start at 6, go down 2 over 1, 2, 3, 4, 5. Well, that's looking pretty good. Down over 1, 2, and then over 5. 1, 2, 3, 4, 5. That's looking about right on the line that I drew. So I'm thinking right away that it's going to be the first one there, down 2 over 5. But let's test the other one just in case. It says down 5 over 2. So I'm going to go down 1, 2, 3, 4, 5 over 2. I don't need to test anymore. That's definitely not the line that's fitting this data.